right, guys, so we are starting a new unit today. We are in Unit 11. This whole unit is about circles. We are going to skip the do now and jump right into the lesson. So before we can actually do problems, we have to go over some vocabulary, which I'm sure you're pretty familiar with. Let's go over the definition of a circle. The circle is the set of all points in a plane that are equidistant from a given point called the center. A circle is named by its center. So for example, let's say we call this point O. This is the center of the circle. And the way we would shortcut this, well, this would be called circle O. But the way we're going to shortcut it is a picture of a circle with the center dot in the middle and then the name of that point, which is O. So this would be called circle O. Next vocab word is a radius. A radius is the distance from the center to a point on the circle. And we remember we did proofs with circles and radii. We know all radii of a circle are congruent. So basically, any segment from the center to the rim of a circle, from the center to the rim, is all the same distance from that center point. So all those radii are congruent. So one is a radius, more than one are called radii. Okay, so here's a new vocab word, a chord. A chord, or I'm sorry, a segment joining any 2 points on the circle. So basically a chord has to go from rim to rim. So it's a segment joining any 2 points on the rim of the circle. So there's chord AB. Now the most popular chord that we know of is the diameter, right? A diameter, we'll talk about this in a little while, but a diameter is a chord, and not only does it go from rim to rim, oh, we can't use B, we've already used B, we could call it D. But it also has to go through the center of a circle. So we'll talk about the diameter. Let's erase this. We'll talk about a diameter on the next page. Okay, there we go. A segment, or sorry, a chord that passes through the center of a circle. The diameter is 2 times the radius. So like we said, the chord is probably the diameter is probably the most special chord we know, right, that a circle can have, because not only is it a chord, meaning it's going from rim to rim, but it's also passing right through the center. And if you notice, a diameter is made up of 2 radii. So from A to the center is equal to the center to B. So 2 radii make up a diameter. 2 or more concentric circles, or 2 or more coplanar circles with the same center. Let's erase that. Oh no, I've lost our page. Let's go back. Sorry about that. 2 or more coplanar circles with the same center. Coplanar just means they're existing in the same plane. So if you notice, I have 2 circles in this diagram. One is obviously bigger than the other. Let's call this center point O, but they both have that same center O. Okay, some more fill-ins. Inside or in the interior of a circle, if its distance from the center is less than the radius. So a point is considered inside or in the interior if the length of the distance from the center to that point is less than the radius. So for example, look real quick in our diagram from O to A. A is in the interior of the circle because that segment length from O to A is less than the radius would be. Okay, next one. A point is considered outside or in the exterior, exterior means outside, exterior of a circle if its distance from the center is greater than the radius. And a point is considered on the circle if its distance from the center is equal to the radius. So let's look at this little diagram. Let's find a point that's on the interior and the exterior and on the circle. So like we said before, point A is considered in the interior because the distance from O to A is less than the radius. So point A is considered in the interior. C is considered in the exterior right here because the distance from O to C is extending well past the radius. So C is considered in the exterior of the circle. And last but not least, B is considered on the circle because from O to B is the same length as the radius. Okay, so I want you to take a minute right now, pause the video, answer all of these questions, and once you've answered them all, play the video again to see if you got them correct. So we want to name all of the radii. Well, remember, the radius has to start from the center and go to the rim. So we have segments OA, OB, OC, OE, and OF are all radii. Now you could have listed those in any order. There's no specific order that they had to be listed. I'm going to ask you a question and you answer to yourself. Why is BD not considered a radius? Why is segment BD not considered a radius? Okay, I think you got it. It's not considered a radius because it's not coming from the center of the circle. Okay, now we want to name all chords. Now remember, a chord has to go from rim to rim. So it's a segment where its two endpoints are both on the rim of the circle. So here we have the diameter is a chord. So we have diameter or chord AB. Another chord is, I don't know if you see it right there, but that's point E. So FE is another chord. And we have one more, which is BD. We want to name the diameter of the circle. So you can have more than one diameter like we do in this example. AB is a diameter, but also FE is a diameter. And now I'm telling you, if CO is 3.5, we want to find AB. Well, CO is a radius, so that means AO is 3.5 and OB is also 3.5. So AB, the diameter, is going to be 3.5 plus another 3.5, or 3.5 times 2, which is 7. And for the last question on this problem, it is telling us if AB, so basically they're telling us the whole diameter is 18, find the length of BO, which is half the diameter. So that's going to be 18 divided by 2, which is 9. Alrighty, next page. Okay, definition. The distance from the center of a circle to a chord is the measure of the perpendicular segment from that center to the chord. Okay, what is this saying? It's saying, let's say I have chord. I think this got cut off a little bit. Let's call that point A. But if I have chord AB and I want to find the distance from AB to the center, what I would create is I would create a segment from O to AB, but it would have to be perpendicular. And whatever the length of that perpendicular is, that's going to be the length or the distance from the center to the chord. Let's do an example. So let's say I say in circle O, A to P is 9. So that means this segment A to P, oh, sorry, not 9 is 8. Sorry, A to P is 8. The radius is 17. Find the distance from the center to the circle. So right now, a radius has not been drawn. OP is not a radius because P is not on the rim of the circle. So I'm going to draw my own radius. I'm going to draw a radius from O to B. And I could also draw a radius if I wanted to from O to A. And we know these are both 17. Now we know the supplement of a right angle is a right angle, so we have right angles on both sides here. I'm going to take one of these triangles, APO, I'll choose that one. We have OP, oh, sorry, let's get that back there. Let's fix my P. All right, so we have OPA. We know A to P is 8. We know A to O is 17. We want to find the distance from the center to the chord. Remember, the distance from the center to the chord is the length of that perpendicular segment. So that's going to be my x. And if we look at this, we should be really happy because this is a triple, 8 something 17. X is equal to 15. So the distance from center O to segment AB is 15 units long. Okay, theorem. If a radius or part of a radius, so it doesn't have to actually extend all the way to make it a radius. So if a radius or part of a radius is perpendicular to a chord, then it bisects the chord. And I'm just going to show you why real quick. Let's use the second example. So I have O to E. Now O to E is not a radius, but if we were to extend OE, it would eventually be a radius. So that's why we don't need a full radius for this to work. So it's a radius or part of a radius. It's saying if it's perpendicular, if it makes right angles with a chord, then it's also going to cut that chord into 2 equal parts, meaning AE will have to be congruent to EB. And let me just real quick explain to you why that will work. Now in this diagram, we don't have a radius, but we can draw in a radius. We know a radius is between the center and the rim. And now we learned from our proof days that all radii are congruent. So OA is congruent to OE. Now we also know that OE is congruent to OE for the reflexive. And then we can say that these triangles are congruent by a method called hypotenuse leg. And then because these triangles are congruent, we can CP, AE, and EB. Okay. Do you need to go through that all every time? Absolutely not. You do not need to go through that every time. What do you need to go through? You need to know that if I have a segment coming from the center that's perpendicular to a chord, I can then say the 2 parts of that chord are congruent. That if a segment is from the center perpendicular to a chord, then it bisects the chord. And the vice versa, the reverse of that is also true. If a radius or part of a radius bisects the chord, then it is perpendicular to that chord. So if you see in this diagram, OD bisects AB, then we can say we have actually 4 right angles right over here. Or in this case, OE is perpendicular, bisects AB. We have the 2 right angles over here. All right, let's do some problems. I think we're ready. So let's look at our given information. We have circle O, and that's a really important piece of given information because it's identifying for us which point is the center. They're telling us the radius is 25 and AB is 30. So I'm going to hold off on that radius for just a minute, but we know AB is 30. We also know if there's a segment coming from the center of the circle perpendicular to a chord, it's going to bisect. So each part of this will be 15. Now I want to find the distance from the chord to the center. So I need to find the length of that perpendicular. What I'm going to do is I'm going to take one of these and I'm going to draw a radius, and it doesn't matter which radius you choose to draw in. I'll draw an O to A, and I know this is 25. So you might be thinking right now, well, 15 something 25, that's not a triple. But if I take this 15, 25, and I divide this triangle, I'm going to reduce this triangle by dividing by 5. I'm going to get a new smaller triangle, and it's going to be a 3 and a 5. And this is a triple. It's a 3, 4, 5. Now that length of the perpendicular is not 4. Because we divided by 5, we have to go back and multiply by 5. So we are going to get x is equal to 5 times 4, which is 20. So the distance from the center to the chord is 20 units long. Okay, let's try another one. It says we have circle P, so that means the center of our circle is P. The radius of the circle is 10, and AB is 16. So we know chord A to B is 16. We know if we have a perpendicular from the center, it will also bisect it, so it will turn into 8 and 8. Now our radius is 10, so I'm going to draw in one of my radii. We'll say that is 10. And we want to find M to C. So now I don't know the full length of M to C. I don't know the length of M to C, but I do know that P to C, let me just erase, I can't really see my C right there, there's your C. We know P to C is a radius. It's coming from the center, and touching the rim. So we know P to C is in fact 10 units long. I'm going to write that down. C to P is 10. Now we want to find just the length of M to C. I can't make a circle, I can't make a triangle there. It's not going to help me because C to A is not a radius, so that's not going to work. But what I am going to do is use triangle AMP. I'm going to use triangle AMP, and I'm going to redraw it. AMP, and I have an 8 and a 10. If I divide that triangle by 2, I'm going to have a 4 and a 5, and once again, we have a 3, 4, 5. Don't forget to multiply back by 2. So M to P is 6. Why is this so helpful to us? It's so helpful to us because we know that C to P is a radius, so that's 10. So we're going to say the whole length is 10, the top part is 6, 10 minus 6 is 4. And that's the length of C to M, or M to C, 4 units long. All right, next one. Here we have circle O. So we have a circle with center O. It's telling us that the radius is 5. So I'm going to go ahead and I'm going to label my radius. So O to C is a radius. We also know O to A is a radius. But look at these little markings right here. O to C has 1 slash and C to B has 1 slash, which tells us these are the same length. So that means C to B is also 5. We want to find segment AB. That's our X. So let's look at this. I'm going to redraw. If you notice, we have a right triangle. Here's our right triangle, BAO. I'm going to redraw this right triangle. So we have BAO. We know O to A is 5. We know O to B is not 5, but it's 5 plus 5, which is 10. And then we will have an X. So you can absolutely reduce this triangle. This is not a triple. You can reduce this triangle, divide by 5. And we'd have a 1 and a 2. Let's call this side Y. And I'm going to say y squared plus 1 squared equals 2 squared. So we're going to have y squared plus 1 equals 4. We're going to have y squared is equal to 3. So y is equal to the root of 3. Okay, but we didn't want y. We divided by 5. So we got to go back and multiply by 5. So what is x going to equal? It's going to be 5 root 3. So what's the length of AB? AB is 5 root 3. Okay, next one. So once again, we have circle C. The radius of circle C is 13. We want to find all of AB. Well, we know that if a segment is perpendicular, it will also bisect it as long as it's coming from the center. So as long as I find the length of one of these segments, I'll be able to find the whole length of A to B. So I'm going to go ahead and I'm going to draw in my radius from C to A, and I know that's 13. And if you notice, we have a 5, a 13, this is a triple, 5, 12, 13, which means this other segment is 12, and A to B is 24 units long. Okay. Here we have circle X. So that's telling us looks a little bit different, but X is the center of our circle. We have a diameter that's 30 units long. What does that mean? Let's call this point C over here, and let's call this point D, just so I could reference them. This is telling us that from A to C is 30. We're being told that A to B is 18. But remember, if a segment from the center is perpendicular to a chord, it bisects it. So here we're going to have 9 and 9. And now we want to find the distance from the distance from the center to A and B, from AB to the center. So I can't use X because I have a point X here, but let's call this Y. That's what we want to find. Now, what I want you to, that I hope that you realize is that C to A, that's a diameter that's going, obviously it's a diameter, it's going through the center of the circle. So that means X to A and X to C are radii. And what do we know about all radii? They have to be congruent. So if C to A is 30, then X to A is 15, and X to C is also 15. And now I have all the information I need to find X to D. I'm sorry, segment XD. Now remember, if we have a right angle on one side, the supplement of it will also be a right angle. We have Y here, D, 9 and 15. This is the triangle DAX. Now, I'm going to shortcut this real quick, but if you divide by 3, it's going to be a 3, 4, 5. So to multiply back, y will be 12. So the distance from A to B is 12 units long. Okay, last one on this page. So it says, given circle M, the radius is 25 and A to B is 48. Remember, AB is a chord, M is the center. That means we are perpendicular to a center segment from the center. Our radius is perpendicular. It also bisects. So we are 24 and 24. We have our radius is 25. So I'm going to draw in my 25. And if you look at this triangle we have right here, this is a triple, something 24, 25. That is 7, 24, 25. So we wanted to find MN. That's 7. Oh, but first they asked us to find MO. I'm jumping the gun here. Well, isn't MO a radius, right? Center to rim, that's a radius. So we want the segment from the center to a rim. We know all radii are 25 because it says the radius is 25, which means MO is 25. Now, how are we going to find NO? Well, the whole MO is 25 and NM is 7. So we're just going to take those two segments and subtract them, those two segment lengths, and subtract them. So we are 25 minus 7, and we will get 18 for length NO. Okay, we are moving on to our last page for today. These problems are definitely a little bit more involved, but we got this. So it says the radius of a circle O is 26 millimeters. The length of chord PQ is 20 millimeters. Find the distance from the chord PQ to the center. So we're coming up with our own diagram here. So I'm going to start off where it says the length of chord PQ is 20 millimeters. So I'm going to go and I'm going to draw my PQ right over here. Here's my P to Q. Now I know P to Q is 26 millimeters. They want us to find the distance from chord PQ to the center. Well, remember the distance from the center to a chord is the length of its perpendicular. So this is what we're trying to find. Call it X. Now, the one thing we didn't fill in is saying that the radius is 26. So I'm going to go ahead and I'm going to draw in the radius. I'm going to draw an O to P, and that's 26. Oh, guys, I labeled this wrong. I'm so sorry. Backtrack. PQ is 20. I labeled it as 26. P to Q is 20. Let's fix that. Now, remember, if a segment is perpendicular from the center to a chord, then it also bisects it. So that 20 is going to get split into 10 and 10. So let's look at this triangle. We have a 10 and a 26. Oh, not an X. I'm just messing up here left and right. All right, so we have a 10 and a 26, and we're trying to find X. I'm going to go ahead and I'm going to reduce this triangle by dividing by 2. When I reduce that triangle, I'm going to get a 5 and a 13. And we're going to call this side, well, actually, we don't have to call it anything, because it's a triple. Something 5, something 13. It is 5, 12, 13. Go back, we're going to multiply by 2. So X will be 24. So find the distance from PQ to the center. We're going to get 24 millimeters. Our answer. Okay, next one. It says 2 intersecting circles have a common chord that has a length of 16. The radius of one circle is 10 and the radius of the other is 17. Find the distance between the centers of the 2 circles. Okay, guys, I'm going to put a star next to this problem because anytime I give you a problem with a common chord, we're going to go about this the same exact way every time. We're going to have this Venn diagram looking thing with 2 circles that are overlapping. What you want to do is we're going to take that common chord. That means it's a chord that's in both circles. And I'm going to draw that chord right in the middle of their intersections. And just for fun, let's name these circles. So this could be circle P. This could be circle Q. I'm going to call this point A, and I'm going to call this point B. And once you draw that common chord right in the middle, it has a length of 16. We're going to hold on to that for a minute. We're not going to label that just yet. The radius of one circle is 10 and the radius of the other circle is 17. Obviously, the bigger circle we will label with the bigger radius, just so it makes sense in our head. So I'm going to go ahead and I'm going to draw in radii, but I'm not just going to draw in one radius per circle. I'm going to draw in 2. So I'm going to draw a radius from P to A. I'm also going to draw a radius from P to B. And those radii have a length of 10 and 10. Then I'm going to go to the other circle. I'm going to go to the bigger circle, and I'm going to draw a radius in there. I'm going to draw a radius from Q to A, and I'm going to draw a radius from Q to B. And that circle is going to have a bigger radius, so we know that one is 17. So Q to A is 17, and Q to B is 17. Now guys, I don't know if you've realized this, but we have created a kite. Top two sides are congruent, bottom two sides are congruent. That is absolutely a kite. So now we can use all the properties of a kite to help us out. So it says find the distance between the centers of the two circles. So I'm going to find the distance from P to Q. That's what we want to find. Let's call this point of intersection with the common chord that we're told. Let's call this point W. Now remember, in a kite, there's 4 right angles in the middle. And not only that, but the long diagonal splits the short diagonal into 2 equal parts. So it said that common chord has a length of 16, so that's going to be 8 and 8. I'm just going to clean this up a little bit because it's getting a little bit too crowded in here. Okay, so we know we have those right angles in the middle. All right, now we have a bunch of different right triangles going on over here. We have, let me highlight in yellow. We have this right triangle where it's 8 something 17, and that is absolutely a triple. It is a 15 17. But then we have another triple also. Let me highlight it. Well, not a direct triple. We have something 8 10. Well, if you divide this by 2, if you take the 8 and the 10 and you divide it by 2, we're going to get a 4 and a 5. So this is a 3, 4, 5. Don't forget to multiply back. So that bottom side is a 6. Now the length between the two centers from P to Q is not 6 and it's not 15. It is 6 plus 15, which is 21, and that's our answer. 21 units long between P and Q. Okay, we're going to have one more problem to do, and then we are calling it a day. So here we have, if A to C is 60 units long, angle ABC is 120, find the distance from the chord to the center. So remember, the distance from the center to the chord is the perpendicular. That's going to split that 60 into 2 30s, and that 120 is going to get split into 2 60s. So what do I hope that you realize? I hope that you realize we have a special kind of triangle right here. Let's write this out. So we have an A and a B. This is 60 degrees. This is 90, which means the last angle has to be 30. And here we are. Oh, don't forget to write this as 30. Opposite the 30 is x. Opposite the 60 is x root 3. And opposite the 90 is 2x. So our equation is going to be x root 3 is equal to 30. Let's solve for x. Divide by root 3 on both sides. We're going to get x is equal to, multiply by root 3, we have to rationalize this, 30 root 3 over 3. X will equal 10 root 3. And that is going to be the length from our center to our chord. So our answer is 10√3. Okay, guys and girls, so we are done with today's lesson. I want you to go through and make sure you understand all the aspects of this, and we will touch base with more practice on this tomorrow.